So this is 3.5 derivatives of trig functions. We're going to add 6 more rules of derivatives to your list of 7 that we've done so far. So derivative of sine of x with respect to x is equal to cosine of x. And we're going to use that to do the derivative on example 1. So it says find y prime where y is equal to x cubed sine of x. So y prime by the product rule is equal to the second function, which is sine of x, times the derivative of the first, which is 3x squared, plus the first function, x cubed, times the derivative of the second, which is our new derivative. Derivative of sine is cosine of x, and that's it. So the next derivative, we would group these two together, is derivative of cosine is equal to negative sine of x. And so we're going to use that combined with the quotient rule on this next one. So dy dx is equal to, by the quotient rule, the bottom function times the derivative of the top, and the derivative of x is 1, minus the top function x times the derivative, I can't say derivatives, derivative of the bottom. So derivative of 1 is 0, derivative of cosine is negative sine x, and then all over 1 plus cosine of x quantity squared. You could clean that up. One way to check this would be to use your calculator. You can actually type in the derivative of cosine on your calculator. We'll see that it looks like negative sine of x. So let's do that right now. So if you type in y equals, go to the math button, and it's number 8, and we type in derivative with respect to x of cosine of x with respect to x, and if I graph this, just hit zoom and z standard or z trig, either one, try z trig, we'll see that we have the inverted sine function. So it's right here. See it happening from here to here is one cycle of sine flipped over the x-axis, so that is negative sine of x. You can check your derivatives by graphing the derivative along with whatever you got when you use the rule to get the derivative, and see if they match up. All right, so moving along to the next grouping here, we've got tangent. Derivative of tangent is secant squared. And then derivative of cotangent is negative cosecant squared. So we group those two together. And then the last two we usually group together. So we've got derivative of secant is secant tangent, and derivative of cosecant is negative cosecant cotangent. So if I am asked to find second derivative of secant of x, first derivative, we'd have to find that first. First derivative of secant is secant x, tangent x. And then the second derivative, you're going to have to use the product rule on. It's going to be derivative of, or take the second function, tangent of x, times derivative of the first, which is secant x, tangent x, plus derivative for the second function, secant of x, times derivative of the second, which is secant squared x. So there's your second derivative. All right, and then we have one more physics definition for you guys, and that is the third derivative of the position function in physics, or the first derivative of acceleration, is called jerk. Yeah, it's the change in acceleration.
Yeah, Jordan looked that up, so we were calling each other.
I think we'll have to use it in here. So.
See you, Mr. Arms.
See you later. So you don't want to be called a third derivative at all. It would be a bad thing. All right, so what we do here is find velocity, which is going to be equal to the first derivative of position, using our new derivative rules. Derivative of sine is cosine of t Derivative of cosine is negative sine of t. Speed is defined to be the absolute value of velocity. And so the absolute value of this function, you just put absolute value symbols around this guy. So there's our speed. Acceleration, a of t, is equal to the second derivative of the position function, or the first derivative of velocity, which is derivative of cosine is negative sine of t. Derivative of sine is cosine. And then finally, we've got jerk. So jerk is called j of t. It's equal to the third derivative of the position function. Derivative of sine is cosine. Still have the negative out there. Derivative of cosine is negative sine. So it'd be negative sine or positive sine of t. So this kind of looks similar to like those powers of I that we've done before back in Algebra 2 and in pre-calculus. So keep cycling through. And then once you have those four functions along with your calculator, it's probably the best way to do it with your calculators, you can find the smallest and largest position, smallest and largest speed, acceleration, and jerk. Just graph those. Now, one key is on your graphing calculator. When you go to graph this guy right here, you can go to Math, Num, and there's an ABS for absolute value, and you could type in ABS and place cosine t minus sine t between the two absolute value functions. So then you can find what the highest speed is. It's cycling, so you're going to, the highest speed, it happens at each top of the function and each bottom as well. And then acceleration, same thing. Just graph those functions together, look for the highest it reaches and the lowest it reaches. Same thing with jerk. But I would just do it on your graphing calculator, even though in the textbook they suggest that you think about it. But go ahead and graph these to see what it looks like. They're periodic functions, and look for the highest and lowest functions. And they just keep repeating over and over again. So you'll see clearly the y value is the smallest or largest position, speed, acceleration, or jerk, and then it will happen at multiple values of x in radians. So check that on your graphing calculator. Once again, just quickly here, if you go to Math, over to Num, you'll see the absolute value right here. So you'll need to access that to graph that speed function. And then you can tell me the highest and lowest that those functions attain. All right, hope this is helpful. That's it for today's lesson.